trigonometric functions using fundamental identities. Do not draw the right triangle. So I'm going to start by writing down sine squared plus cosine squared equals 1. Okay, so I know what the cosine is. By the way, notice it says that the sine value will be greater than 0. We're going to apply that in a little bit. So I'm going to plug this in for cosine here. So I have sine squared x plus, the cosine is negative 4/5 squared equals 1. I'm going to go ahead before I do anything else, and I'm going to expand this. So I'm going to write negative 4/5 times negative 4/5, because I'm writing this quantity twice. Valeria, you are going to take Natalia's spot. A negative times a negative is a positive, and 4 times 4 is 16, 5 times 5 is 25, equals 1. Sine squared x, I want to move this to the opposite side. It's positive. The inverse operation would be to subtract it, so I'm going to subtract 16 over 25. By the way, I'm going to do this all without a calculator. Could we use a calculator? Absolutely. So how can I rewrite 1? How can I rewrite the value of 1, keeping that same value, but as a fraction? Well, I know that I can write it as 25 over 25. 25 over 25 is still 1. 25 minus 16 is 9. I have 9 over 25 equals squared x. Now, how do I isolate the x? Okay, I take the square root of both, and now I'm able to see that I have the sine is equal to plus or minus the square root of 9 is 3, the square root of 25 is 5. But if we go back here, it says sine has to be greater than 0, so it has to be positive. So I get to cross this portion out. So I'm going to come back up here, I'm going to find sine, and I have a positive 3/5. My cosine is a negative 4/5. Now what I'm going to show you next, some of you are just going to be able to visually see this and you wouldn't have to go through this detail, but I'll do it a little bit the long way here. We know the tangent of x is equal to the sine of x over the cosine of x. And I could write that as sine divided by cosine. So here's my sine. My sine is positive 3/5 divided by a negative 4/5. And this will achieve what the tangent is. When I divide fractions, I turn division into multiplying, and I have times a negative 5/4. The 5s are going to reduce down to 1, and I have a negative 3/4. Negative 3/4. Okay, so how do I find the cosecant, secant, and cotangent? It's just the reciprocals of the 3 primary trig functions, 5/3, negative 5/4, and negative 4/3. By the way, let's just test your understanding of the unit circle. Turn to your partner. What quadrant would this lie in based on these 6 trig? Let's look at number 2. So number 2 from the Try These Fundamental Identities, number 1. If you've just came in, you're going to see 2 packets in back. Make sure you grab both packets. We will be using both packets today. All right, so here's the first thing I would do. If you have not written down the 3 trigonometric identities, I would put those at the very top of this paper. We will be deciding which one do I use for each problem, and some problems will use more than one. We'll see an example of that in this particular problem. So I see cotangent. My eye is naturally drawn to using the 3rd trig identity that you see in my list. So I'm going to write it down. Cotangent squared theta plus 1 equals cosecant squared theta. Then I'm going to replace, in this position, I'm going to replace my 4. And I could put 1 over here if I want to. So this is 4. The cotangent, right here it is. The cotangent is 4, but I want to do the cotangent squared. And that equals the cosecant squared. So 4 squared is 16, and 16 plus 1 is 17. I'm going to take the square root of this. Keep in mind that sine has to be less than 0. Sine has to be less than 0. So now I have the cosecant would be equal to plus and minus the square root of 17. Now cosecant is simply the reciprocal of sine. So if sine is less than 0 or negative, if sine is negative, that means its reciprocal has to also be negative. So I'm going to cross out the positive symbol. And then this is 1 of my 6. I think I'm going to come up to the top and write sine of theta, cosine and tangent, and then we have the secondary trig functions. Okay, so I already know that the cotangent is 4. Cotangent is 4. Well, by the way, if cotangent is just the reciprocal of tangent, then I'm just going to take 1 over 4 will be the tangent. And then if the cosecant is negative radical 17, I know that the sign will also be negative. Now, how do I find the sign? So I need to take the reciprocal of this. So 1 over negative radical 17. Mathematically, that's not wrong. It's just not proper. So I'm going to multiply both the top and the bottom by the square root of 17. I'm left with the square root of 17 over square root of 17 times the square root of 17 is simply 17, and then we do have a negative sign. It doesn't matter if the negative sign's on top, on the bottom, or in the middle, as long as there's 1. This will be the sign. So negative radical 17 over 17. Okay, so now I have to go, how can I achieve the cosine and the secant without drawing? We cannot draw a triangle in the situation. So I'm going to come back here and look here and go, okay, I have the sine, and I need to figure out what the cosine is. Okay, so I'm going to go back to this first trigonometric identity and write sine squared. You should be writing this down as well. Sine squared plus cosine squared equals 1. I'm going to replace sine with what sine is equivalent to. I'm going to expand this by writing it down twice. Whoops. Okay, a negative times a negative is a positive. Got it? And square root of 17 times square root of 17 is simply 17. And then I have 17 squared in the bottom, so 17 times 17. Well, the 17s are going to reduce down to 1, and I have 1 over 17. So if I rewrite this, I have 1 over 17 plus cosine squared theta equals 1. How do I isolate cosine? I'm going to move this to the opposite side. It was positive. When it moves over, it will become negative. So 1 subtract 1 over 17. Let me just pause. What's next with this? As I try to isolate the cosine, I'm going to rewrite 1 as 17 over 17 because 17 divided by 17 is equivalent to 1. And I get 17 minus 1 is 16 over 17 equals cosine squared. All right, here's my next thing. I'm going to take the square root, I'm going to take the square root, and now I'm going to grab a different piece of paper where I can continue to show my work. Give me 1 second. I'm going to bring this up here so everybody can see that. Nothing that I've done is wrong, but mathematically, to put this in a proper form, it's going to take a little bit of time. So I should have 2 answers. I should have a plus or a minus. Okay, I've got that. And we have the cosine of theta is equal to the square root of 16 over the square root of 17. Well, the square root of 16, that's easy. That is going to be 4. So it's going to be 4 over the square root of 17. Bless you. Nothing about that is wrong. This isn't wrong, but I can't leave a final answer, excuse me, with the square root on the bottom. So times the square root of 17 times the square root of 17. And I'm left with 4 square roots of 17 over 17. Now I have to decide, is this positive or negative? Let's go back to this original problem. So I know that this is my answer. It's 4 radical 17 over 17. So I'm going to put that right here. 4 radical 17 over 17. And now let's evaluate this. You ready? If tangent is positive and sine is negative, would cosine have to be positive or negative? Remember, tangent is sine divided by cosine. Tangent is sine divided by cosine. So if I have to end up with a positive here, and I have a negative for the sine, does that make cosine positive or negative? Negative. Okay, now I need to take the reciprocal of this. I always like to do the least amount of work. So I'm going to come back to, where was it? Right here. This was my answer before I made it proper. This was the cosine before I made it proper. So if I simply take the reciprocal, it would be radical 17 over 4. Radical 17 over 4. Radical 17 over 4. Again, if cosine, the primary trig function, is negative, then the secondary trig function will follow the same. Positive, negative, 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 positive, positive. Okay, so they misnumbered these. So if we look at our paper of the try these, it goes 1, 2, and then we're going to jump down here. We're going to jump down to 5, 6, 7, 8. So we do not see a 3 and 4. You're not just missing that. Okay, we are going to continuously refer back to these, and you do have to have these memorized. You do have to have these memorized. It may be helpful if I provide you with. It may be helpful if I provide you with. Flashcards to memorize these, but these absolutely have to be memorized. So let's get started right now. I'm going to fold my paper just so that we're able to see both the top and the bottom. It says use the fundamental identities to simplify the trigonometric expressions. Give me 1 second to fold here. And we are looking right now. Oh, that's an ugly fold. We are looking right now at number 5. Okay, here we go. So how can I rewrite cotangent? Cotangent is the reciprocal of tangent. So if tangent is sine over cosine, if tangent is sine over cosine, then cotangent is cosine over sine. So I'm going to write this as cosine of x over sine of x. I'll give you a chance to do the same. Tangent is sine over cosine. Sine of x over cosine of x. Now, this is where it's important that you understand that often in lower level mathematics, when they're teaching you to reduce, they say things like these cancel out, like they just go away. But what do they really turn into? 1. They turn into 1s. And these turn into 1s as well. You're always able to simplify when you're multiplying quantities, anything on top with anything on the bottom. So now I have 1 times 1 is 1, and 1 times 1 is 1. 1 over 1 is equal to 1. Check with your partner before we move on to number 6. Okay, so I recognize that when you're first starting to see this, you see secant, and what you're accustomed to seeing is that secant is reciprocal of cosine. So it may be really easy to want to write this as 1 over cosine squared, but if we look up here, does everybody see secant squared right here? So we need to show our work with this. So I have tangent squared theta plus 1 equals secant squared theta. So I can move the 1 to the opposite side by doing the additive inverse. It just means the opposite. So opposite of adding is subtracting. I get secant squared theta minus 1. That's exactly what I had. So guess what this is equivalent to? Tangent squared theta. Check with your partner, please. Make sure you understand. Let's look at the next one. So in the same idea, when I see 1 minus sine squared, look up here. Which function, turn to your partner, which of these identities do you think that we could translate to equal 1 minus sine squared theta? The first one. What would I have to move? Take the sine squared and move it to the opposite side, right? So opposite of adding sine squared would be subtracting. So 1 minus sine squared is actually equivalent to cosine squared. So this is equal to cosine squared over cosine. Bless you. Cosine squared is really cosine of theta times the cosine of theta. It's 2 of them. We just expanded it. And now I'm able, doesn't matter which one I choose, I'm able to cancel 1 on top with 1 on the bottom. But you have to recognize when you cancel, really they're turning into 1. So what is the only thing I'm left with is the cosine of theta. Or you could write the cosine of theta over 1. Okay, let's go on to our last one. Our last one here. All right, so I'm thinking, what can I do here? Well, I know that cosecant is the secondary, it's the secondary trig function. It's actually the reciprocal of sine. So I'm going to rewrite this as cosine squared theta, and then cosecant is 1 over sine. In this case, 1 over sine squared theta. When I multiply, I get cosine squared theta over sine squared theta. And what is cosine squared theta over sine squared? Well, cosine over sine is cotangent. So this is cotangent squared theta. Please now take out this packet. Take out this packet. Flip to the first one. And the very first thing I want you to do is, we may not have room there. Let's do it here. I want you to start by writing